to simplify or ultimately solve an algebraic equation that's got a lot going on, including parentheses. Ideally, you would take care of inside the parentheses first, and if possible, and then work with combining like terms and all that stuff. So taking care of the parentheses sometimes means combining the like terms inside or doing the computations inside, but other times it means just applying that distributive property. So we're going to have 5 examples that we'll do together. The journal says make sure you take care of inside the parentheses, but if you don't, you're still going to get the same result. And that's what we're going to look at in a couple of our examples. So it's best to simplify by combining like terms, or in general, doing operations. In parentheses, yeah, I went off the page, if possible. Then if you still have parentheses because you can't do computations inside, you have x's and y's, can't add those together, then you're going to use your distributive property. Distributive property. Not doing so. It did not get rid of the U. Distributive property, if necessary. And finally, finish combining like terms. So again, when we're using distributive property, you don't have to outright explicitly show, I'm going to do the 2 on the outside times the 3x, and I'm going to do the 2 on the outside times the 7. You could actually just do those computations. There was a little bit of confusion in this morning's class about trying to do 2 times, say, 3x. Because they were like, but I don't have like terms. Now, like terms is just when I need to add or subtract. If I need to multiply 2 times 3x's, that means I have 2 groups of 3x's, therefore I have 6 x's. So you just multiply the number with the coefficient of the variable, because you then have twice the amount of variable, or you have 4 times the amount of variable, and so on. So for this one, problem number 1, or example number 1, 4m minus 3 with a 2 on the outside of parentheses. Can I do any computations inside the parentheses? I cannot at this point, because the only thing I would be able to do in theory would be combining like terms, because all I have is subtraction there, and I can't do that. So what would I get if I apply the distributive property to this expression?
8m minus 6.
So 8m minus 6. I don't have to write, I'm going to do 4m times 2, and I'm going to do 3 times 2 like the first couple of lessons in Unit 9. I can just actually do that computation. And again, if you're not 100% comfortable with the distributive property yet, you could use the arrows to remind yourself it's going to distribute to that, and it's going to distribute to that. And that's as simplified as that particular expression can be. There could be a situation where it says equal such and such, because we could ultimately end up solving for the variable. But in this case, all we're focusing on is simplifying. Number 2 has a couple of different options on how to solve it. So who has an idea of one way we could go about simplifying 6r and parentheses 3 minus 1? Okay, there's more than one way. Who's got an idea how you might want to start it? Yes, sir.
Parentheses, so this is 6r plus 2.
So according to the journal and according to the ideal, 6r and then times 2. Or you could even leave it in parentheses. Parentheses means multiplication. So you can take care of the 3 minus 1 first, initially. But some people are so into the distributive property mode, from using it here, there, and everywhere, that they'll go the distributive property first. So, and what do we get when we do 6r times 2? If I have 2 groups of 6r, What do I have? At 12R. So again, that same problem could be doing with the distributive property instead. So 6R times the 3 minus 1. If someone didn't notice that they could take care of inside parentheses, they would do the 6R times 3 is 18R, minus the 6R times 1 is 6R. And then when they combine like terms, they would still get 12R. So it's okay if you're going distributive property happy and doing more problems with distributive property than you need. Example number 3. 10, and then in parentheses 2n minus 3, and then outside parentheses plus 6. A lot of people, I came up with these examples through the years because a lot of people want to combine like terms at this point. Oh, the minus 3 and the plus 6, that's going to be, ultimately it's not going to be a minus 3. So you have to deal with the distributive property in this case first. And what do I get as my first rewrite when I apply the distributive property? Yes, sir?
20n minus 30n.
30n?
Oh, what's 30?
Just the 30, yeah.
There's no n. And plus 6.
And don't forget the plus 6 tagging along for the ride. Now I can combine my terms, and what would I get as my simplified expression for this third example? Yes, ma'am?
20n minus 24.
20n minus 24. So subtracting 30 and then going up 6 ends up with the result of subtracting 24. Example number 4. Minus, or negative rather, 5k plus, in parentheses, 3k minus 8, and then the 4 on the outside of the parentheses. Again, just because I see k's here and k's here, I'm not ready yet to combine like terms. That's the big warning on these examples. Don't combine like terms, because this needs to be dealt with first. So who can tell me what the first rewrite's going to look like? Yes, ma'am.
Minus 5k
Do the same thing. Negative 5k, it's hard to break down habit.
plus 12k minus 3.
So distribute that 4 into the parentheses first. You have to deal with the parentheses before you get to the combining like term overall. That's the big key here. And then what do we get as our simplified expression for number 4? Yes?
7k minus 32.
7k minus 32. It went off the page, but it really is there. And then the last example is an example that can be done in 2 ways again. That's your little warning. But it doesn't matter if you don't do it the preferred way. You're still going to get the same end result if you're careful about it. So who can tell me what the first rewrite would be for them on problem number 5 here? What would you do as your first rewrite?
2 times 9x.
2 times 9x. And then what would you get when you double 9x? You have 9x's, you're going to double them. Yes, sir. 18x. As opposed to doing it with the distributive property. Alright. Distributive property, we're going to get the same result, even if we didn't prove a little distributive property happy. We get 8x plus 10x to get the 18x. So the big key is to deal with your parentheses first.